Okay, welcome back to our class. So for our final for week module number 7, our topic is all about superposition theorem. So in any electrical network, the current flowing in any resistor is equal to the algebraic sum of the currents delivered by each independent sources, assuming that each source will operate alone. So kaning superposition theorem di ay kay mo ni siya ang mga kuan siya algebraic sum of the currents. So kaning nagcurrent nga nag-flow sa ato ang any resistor. So food for the brain, if a given source is operating alone, the other voltage across is short-circuited, while the other current sources are open-circuited. So take note if ang given source nato is operating alone, so naa siya ang voltage across is short-circuited, ang usan pod is open-circuited. So let's try here's atong example for superposition theorem rather. So we have here, find the current in the resistor RL of the network as shown using superposition theorem. So natay given nga circuit. So we have here natay E1 which is 24 volts and E2 which is 26 volts, and our R1 and R2 is 0.4 ohms and our RL will be 0.8 ohms. Take note. So, nag-assume ta ng atong voltage source sa E1 to operate alone. So, therefore, kaning E1 sa ang atoang i-assume. So, sa E1 nato, so our R total or the total resistance is ang kaning R1 ug RL is pwede nato ni siya i-parallel kaning duha. So, therefore, ang ato ang total, so since parallel, so 1 over 1 0.8 plus 1 0.4 plus ang kaning series na sa ato ang R1. So solving for our R total, so we have here 0.4 ohms plus 1. So, formula sa atong parallel sa R total, we have 1 over 0.8 plus 1 over 0.4. So, therefore, our total resistance is 2/3 ohms. So, after na to, masolve sa ato ang total resistance here. So, pwede na nato masolve ang ato ang I total. So, solving for I total. So, E sa itong voltage na operate alone which is 24 divided by sa total resistance nga 2/3. So, our total current will be 36 ampere. So, ang kaning nag-travel sa tuang total current is 36 ampere. So, using the current division concept, so, para ma-solve nato ning I1 dire for our RL, so, solving for our I1, so, pwede ta makagamit sa tuang current division concept sa tuang last topic. So, formula will be I total multiply to R2 over R2 plus RL. So, substitute since given tanan data, we have 36. Multiply R2 0.4 divided by 0.4 plus 0.8. So, ang atong I1 na nag-travel sa RL is 12 amperes. So, after mag-assume sa ato ang E1 for operating alone, so, let's assume po sa ato ang E2, which is ang 26 volts. So, total resistor sa ato ang E2, so, same ra sa atong total ganina which is 2/3 ohms. And for the total current, since lahi ilang voltage, so we have 26 over 2/3. So our total current will be 39 ampere. So we have here our total current for our E2. So solving for our I2 using current division concept gihapon. So I total multiply to R1 over R1 plus RL. Itong na-solve nga total current is 39. R1 na to is 0.4 divide 0.4 plus 0.8. Our I2 will be 13 amperes. Since nakuha na nato atong current, so we can solve for the IL. So kaning IL is the total current flowing in RL is equal to the sum of current I1 delivered by E1 and current I2 delivered by E2. So katong gisolve na to ganina. So IL is equal to I1 plus I2. So for our I1, we have 12 and our I2 is 13. So our IL will be 25 ampere. So this is our final answer. So let's proceed for another topic for your final. So we have source transformation method. So kaning source transformation methods are used for circuit simplification. So to analyze the circuits, we can apply a simple voltage and current divider techniques by using this transformation. So this transformation method can also be used to convert a circuit from Thevenin's equivalent into Norton's equivalent. So take note for our source transformation, a voltage source has an equivalent circuit of a voltage generator in series with resistance, while a current source has an equivalent circuit of a current generator in parallel. So we have here our circuit. So if voltage source to current source, so we have here natay E, then given na resistance. So E over R and parallel sa ato ang R. If current source to voltage source, so we have I parallel to R, so our IR is series sa ato ang R. So let's have an example para mas masabtan. So find the current in the resistor RL of the network as shown using source transformation method. So we have here our example sa ato ang circuit. So we have our E1 24, R1 R2 0.4, RL is 0.8 and E2 is 26 volts. So first we need to transform voltage sources E1 and E2 to its equivalent current sources. So we need to solve for our I1. So we have 24 divided by 0.4 is 60. And for our voltage 2, which is 26. So here we have a 65 amperes. So very easy ra. Since current ang ato ang ano. So for next topic, we have Millman's theorem. So Millman's theorem is a modification of the source transformation method. This method is applicable only to parallel connected sources. So ang Millman's is magamit only in parallel connected sources. So this theorem is given by Jacob Millman. The utility of Millman's theorem is that the number of parallel, take note, sources can be reduced to one equivalent source. So it is also be used in solving network having an unbalanced bridge circuit. So we have here our circuit for Millman's theorem. So, applicable only siya in parallel voltage source. So, we have here E1, E2, E3, and R1, R2, R3, and parallel. So, solving for if unknown ang atong VL here. So, VL formula is equal E1 over R1. Then, so on. Then, same divided by 1 over R1 and so on. So, if isolve na to ang current 1, so we have our formula E1 minus VL over R1. And same sa atong I2, and for our IL, we have VL over RL. So, let's have an example. So, find the current in the resistor RL of the network as shown using Millman's theorem. So, solving. So, first, we need to redraw the circuit. So, ang atong 24 volts is nakaparallel siya sa atong 26. Ang 0.4. And our IL here, and our RL is 0.8 ohms. So, solving for our VL. So, VL formula. So, 24 over 0.4. Substitute lang since given tanan. So, we have 24 divided by 0.4 plus 26 by 0.4. And for our 1 over R1, 0.4 plus for our E2, 0.4 plus ang atong RL. So, we have 1 over 0.8. So, our VL will be, so, naay namali, which is 0.1. So, our VL will be 20 volts. So, take note na sa itong calcio ha, para dili dapat i-check na to. So, nanatay VL. So, pwede na nato masolve ang ato ang IL. So, formula for IL, we have VL over RL. So, VL na nasolve na to is 20 volts divided by sa itong RL nga 0.8. So, our IL will be 25 amperes. So, this is our final answer. So, very easy lang, no? Since it is a formula-based problem. So, let's proceed for Thevenins Theorem. So, a French engineer, so we have here Thevenin, made one of those quantum leaps in 1893. So, Thevenins Theorem may be stated below. It states that any linear circuit containing several energy sources and resistances can be replaced by just one single voltage source in series with a single resistance connected across the load. So, kaning Thevenins Theorem di ay is pwede na to siya ma-replace by one single voltage if daghan given nga linear circuit. So, we have here our circuit. So, any linear circuit. So, pwede na to siya ma-transform in one single voltage source. So, that's why we have EO, RO, and formula for solving IL. So, EO is divided by RO plus RL. So, unsa man ning RO? So, kaning RO is the open circuit resistance looking back into the circuit terminal. And A and B with RL removed. All voltage sources shorted and all current sources open. So, manito ang RO. And for our EO is the open circuit voltage measured at the terminals A and B with RL is removed. So, kanidere. So, that's why manito ang EO. So, na-replace siya. So, let's have an example for this theorem. So, find the current in the resistor RL of the network as shown using Thevenins Theorem. So, very taas ang Thevenins Theorem, but take note lang ta. So, natay given nga circuit. So, same sa tong last problem. So first, we need to solve the RO at the terminals of the RL. So atong RO is parallel. So 1 over parallel sa 0.4 plus 0.4. So our RO will be 0.2 ohms. So after na to ma-solve ang atong RO, we need to solve for our EO at the terminals of the RL. So saan pag-solve sa EO? So redraw our circuit. So we have here, apply KVL around the loop. So Kirchhoff's voltage law. So 26 here. So minus I, kaning I na, pa-enter. So 0.4, kaning duha, minus kaning 24. So equal to 0. So I, pwede na ito na i-solve. So 26 minus, para mas madali, pwede ito mag-solve function. So 0.4 plus 0.4 minus 24 is equal to 0. So, pwede pa niya siya ma-simplify para mas masabtan, pero taas man. So, we have here 2.5 ang atuang amperes. So, apply KVL on a loop passing the 26 volts and EO. So, kanina po dere. So, we have 26. Na-solve naman nato ang I. Substitute. 2.5, 0.4 minus ang kaning EO. So, solving for our EO. So, pwede na to. Transpose na to atong EO. So, 26 minus 2.5, 0.4. So, our EO will be 25 volts. So, na naman tayo, EO. So, pwede na nato ma-solve ang atuang IL. So, solving for IL. So, formula, EO over RO plus RL. Na-solve na nato. So, substitute. We have 25, our EO. Divide 0.2 plus 0.8. Our IL will be 25 amperes. So, this is our final answer for Thevenin's equivalent circuit. So let's have our last theorem for our final. So we have Norton's theorem. So Norton's theorem states that it is possible to simplify any linear circuit, no matter how complex, to an equivalent circuit with just a single current source and a parallel resistance connected to a load. So, kaning Norton's theorem is pwede na to siya ma-solve ang complex basta nalay single current source and parallel resistance connected. So, kaning Thevenins Theorem is identical to that found in the Superposition Theorem. So, all underlying equation must be linear. So, no exponents or roots. So, it states that any linear circuit containing several energy sources and resistances can be replaced by just one single current source in parallel with a single resistance connected across the load. So, mo ni siya. Ang ato ang circuit. So, ang any linear, so pwede na to siya ma-replace by one single current source in parallel. So, that's why we have here in parallel. So formula for IL is equal to ISC multiply to RO divided by RO plus RL. So, kabalo na taon sa ning RO. And ang ISC is the short-circuited current passing to a terminal A and B. So kani mao ni ang short circuit current rather. So let's have our example for Norton's theorem. So for our last example, we have here, find the current in the resistor RL of the network as shown using Norton's theorem. So natay current given. So first, we need to solve for our RO at the terminals of the RL. So same itong ganina. So RO is 0.2. Since gi-replace lang nato dire sa itong terminals A and B. So short circuit the terminals of RL and solve the current flowing in the short circuited terminals. So ganina sa itong last is gi-short circuit nato ang voltage, but here we need to short circuit the current. So for our I1, so 24 divided by 0.4. So kani dire we have 60 amperes. And for our I2, kaning 26 divided 0.4, we have 65 amperes. So our ISC, so total current entering, is equal to current leaving. So I1 plus I2 is equal to 125 amperes. So na-solve na nato ang ato ang short circuit current. So after, we need to solve for our IL. So current sa ato ang RL. So mo ni ato ang equivalent circuit from this circuit. So nanatay kaning gi-replace, na-solve nato 125 amperes. And our RO 0.2 ohms and our RL is 0.8 ohms. So solve nato ang nag-flow diri nga current, which is ang IL. So formula, IL is equal to ISC multiply RO divided by RO plus RL. Substitute 125 ato ang short circuit current multiply RO nga 0.2 divided by 0.2 plus 0.8. So our IL final answer will be 25 amperes. So this is our final answer. So I hope nasabtan for our last module for our final for this subject. So if you have any question, you can comment sa itong Google Classroom para mabasa ni Ma'am ang concern and matubag. So that would be all. So thank you and God bless.